Hi doctor, my name is Narenkumar A, Manohar from RK08 and my metric number is 1811127766 and I am from group 23. The theme that given to us is theme 2 accessibility and mobility of people with disabilities. The title of our project is Smart Transfer Wheelchair and our mentor name is IR Dr. Mohammed Noor Arib and my team leader name is Sheng and my teammates are Hasan, Mohammed Ijmal, Mohammed Faiz. Without wasting of our time, let me talk about the introduction. Okay, what is wheelchair? Wheelchair is a device that provides mobility for users who has mobility impairment. The typically cause of mobility impairment includes spinal cord injury, which lead to quadriplegia or paraplegia. A wheelchair is a useful device in improving the quality of life and independence for people who are unable to walk. Wheelchair is commonly designed for patients with quadriplegia or paraplegia. Quadriplegia is a type of disability where the patient are unable to use their arms, while paraplegia is another disability where the patient have lost their lower part of their body. Okay, the next is there are two types of wheelchair in current market, which is electrically powered wheelchair and conventional manual wheelchair. Okay, move to my next part, which is problem statement. Okay, one of the common vehicle used by disabled person is wheelchair, which is limited in its function as it requires human force to move it. Most of the wheelchair users encounter biggest accessibility issues with getting in and out of the bed. Some people with a lower limb disability need support from others to move them from bed to wheelchair because of their lack of energy to maintain their body weight. On other hand, limited height of wheelchair is also one of the major problems that faced by the wheelchair user. It is because some of the beds that are very high off the ground and it is lead problem to the wheelchair user and it is inconvenient for the wheelchair user to get in and out of the bed and the daily life work of the wheelchair user also affect uh, such as in a higher place. For example, mirror is not usually at their height, so the wheelchair user face difficulty in that situation. So in our project, the priority requirement is to help the user of the wheelchair to be able to get in out of the bed without any help from the from other. At the same time, we create a system that capable the level of desired height of the user of the wheelchair. Moving to my next part, which is objective. Okay, the first one is develop an instruction system capable to ease user mobility with less human energy consumption. And the second one is construct as a system that able to help user accessing bed. The next one is create a system capable to level the desired height according to the user. The fourth is a modify or upgrade ergonomic design in existing wheelchair. So in our project or in our product, we actually modify some parts from the existing wheelchair to get a upgraded vision. Okay. Next, I move to the scope. Okay. This project will focus only paraplegic adult normal size person and weight only. And this wheelchair system is powered by using electric source. Actually, we use a battery 12 24 we actually use a battery actually battery I think 24 watt or 12 watt I think, and modification and design system on the existing wheelchair in the market. And also the wheelchair system is designed for people with lower limb disability only. Actually, how to say, our design is actually we design for the those who are paralyzed for the from the lower part of their body. Okay, move to the last part, which is market survey. Okay, based on market survey, most of the viable wheelchair in current market are electrical wheelchair. There are some same feature for this electrical wheelchair, which is range of carry weight 100 to 200 kg, warranty 1 year, cost 2000 to 6000, speed control 0 to 6 km per hour, battery 24 watt. And based on the 31 feedback, 31 respondents feedback, there are many of them think that some general characteristic of wheelchair is important, which is high load capacity 38.7, lightweight and portable 61.3, durable 64.5, long lifespan 54.8, user friendly 54.8. Based on the survey result, this project is designed a wheelchair which is high load capacity, lightweight, user friendly, small size and low cost wheelchair. So to get a high load capacity, we use a stainless steel in our project to the frame for the strength of the frame. And also stainless steel is also a lightweight. Okay. Last but not least, to conclude that we designed this wheelchair mainly to help the disability person to get into the bed by independently. So to achieve that, we build this wheelchair to help them for their daily life make easy. That's all from me. Thank you.
A very good day to all panelists. So now I will continue the presentation. First of all, let me introduce myself. My name is Chionh Yuan. I'm from RK08 Mechanical Engineering. My matrix number is 171110646. So now I will proceed to the detailed design part. So in this project, we had designed a smart transfer wheelchair to help those patients or other people who are facing mobility difficulties. This transfer wheelchair is suitable for an indoor area and provided a lot of convenience to the wheelchair user. Besides, there are some specific functions for the transfer wheelchair. First, the design of the wheelchair is convenient to transfer the user from a bed to a wheelchair. As we know that there are a lot of wheelchair users is facing difficulty to move themselves from a bed to their wheelchair, from the wheelchair to their bed. So now these wheelchairs are here to solve this problem. Second is the height adjustable. As we know that there are different height of the bed, some may be low height, some will be higher height. So sometimes this is very hard for those users to carry them themselves to the bed. So this function is allow the user to adjust the height of the wheelchair to fit with the height of the bed so that they can easily to carry them themselves. So third is the automatic movement control of wheelchair. So this function is allowed those users to move with the wheelchair with just a press of the button control. So our design consists of 4 key subsystems to success the function above. First is the wheel with braking system. The second is the body frame. Third is the lifting mechanism. And fourth is the controller. So now I will proceed with the wheel of the braking system. The wheel that we choose for this project is a custom wheel. The reason that we choose the custom wheel is because it is cheap and it is easily to find in the current market, and it is easily to assembly and maintenance. The most important reason is because it consists of a braking function and it is able to rotate in 360 degree of rotation. So this is the orthographic drawing of the custom wheel. So next I will proceed to the body frame. Our body frame consists of 2 parts, which is upper frame, and lower frame. The material used for the frame is stainless steel because it is corrosion resistant and high shear strength. This can ensure that the long lifespan of the transfer wheelchair. The material used for the seat is rigid PVC. It is because we must make sure that it can sustain the body's weight. So the material used for the backrest is the PVC foam, because to make sure that our user can be more comfortable. So this is the design for the lower frame, and this is design of the upper frame. Our upper frame will consist of two parts, which is the left side and the right side, and this one is for the right side and this one is for the left side. So this is the design of our seat is in the C shape, which is because we want to decrease the friction between the buttock of the user and the surface of the seat. So this is how the framework. This is the upper frame, and it is insert into the lower frame. It is movable. Yeah. So next is the lifting mechanism system. So the lifting mechanism that we choose for this project is the electric linear actuator. The reason that we chose this linear actuator because we can control the speed of the linear actuator by using electronic devices. It is because it is a safety installation and long lifespan. The most important reason is because it is able to carry weight from 6 kg to 900 kg, depends on the model that we use, and it is very quiet and harmless to the environment. So this is the design of our linear actuator. So next we'll proceed to the controller. So as I mentioned just now, the transfer wheelchair in this project is able to adjust the height of the wheelchair and able to control the movement. So to success these two functions, we need some help from the electronic devices. So Arduino Uno R3 will be the main controller of this control system, because it is able to taking input from the variety switch or sensor and controlling the output such as motor. The advantage of the Arduino Uno board is because the sample size is very small and it's very cheap. Either software or hardware is extremely accessible and very flexible to be customized and extended. In order to make the electronic circuit system, there are some electronic devices must be included. First is the Arduino microcontroller board, and second is the DC motor to control the rotation of the wheel. Next is the DC battery, which is using a power bank with the 5 volt or 12 volt voltage. Next is the jumper wire, which is used for the connection. And next is the driver motor to manipulate the speed of the DC power motor. And last is the push button switch to control to act as an input to send signal to the microcontroller. For the electronic circuit will be more explained on the simulation part. So next I will proceed to the mechanical design part. So this is the design for our transfer wheelchair. There is the isometric view at the back view. So you can see that the wheel there are 4 wheels here with the braking system, and we are using 2 linear actuator as a lifting mechanism, and the upper frame is inserted into the lower frame, and this is how the seat designed and for our transfer wheelchair. So that's all for my part. Thank you. And now I will pass the presentation to my members.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohammed Faiz bin Abu Bakar, and today I would like to explain about the software that we use in this project and the fabrication process. The first software that we use is Arduino IDE. which is the Arduino board set and implemented with the coding created in the software. Next software is Proteus Professional 8, which designed the simulation using schematic diagram of the electrical component sequence to imitate the real application. Next, ANSYS R19.2, which creating working simulation prototype by imitates the working principle into dynamic simulation. The last software that we use is the Autodesk Inventor, which we use for the 3D mechanical design. Next, we move on to the fabrication process. Fabrication is the process of making something from semi-finished or raw material. In the other words, it is the process of making something from scratch rather than assembling something. In this project, we use standardized components such as caster wheel, footrest, mounted motorized wheel kit, linear actuator, electronic components such as Arduino Uno, breadboard, resistor, and jumper wire, which are already available in the market so that we can minimize cost and enhance the quality. However, major frame and pipe hanger material for lower and upper frame for this product is manufactured by custom dimension from extrusion and stamping process in hot or cold working process made by the supplier. The material that we choose for the major frame is stainless steel because it offers high strength and stiffness compared to aluminum metal. Now, I would like to explain about the fabrication process. The process started with measuring all the raw material into desired dimension. First, stainless steel pipe has been cut using saw machine into parts. Several holes were drilled by using corded drill to allow mechanical joining process. Seat and backrest material were cut and removed some material to make a hole to fit on the frame surface before we'll join all the frames as a single upper for right and left frame, also the lower frame. Caster wheel and motorized wheel kit mounted and joined onto lower frame using bolts and nuts, follow with the other upper frame. Next, linear actuator mounted at the bottom of upper frame as required using pipe hanger to secure the actuator base and joined with screw and nuts on actuator rod to the seat frame. Lock plate mechanism then connected also with bolt and nut on upper frame as needed. Lastly, the footrest mounted on lower frame by mechanical fastening. Now we move on the electrical part. The Arduino board sets and implemented with the coding creating in Arduino IDE software. The simulation was designed in Proteus Professional 8 using schematic diagram of the electrical component sequence to imitate the real application, and the simulation ran as required. Next, breadboard were prepared by managing all the electrical components required like jumper wire, wires, resistor, and Arduino board. Finally, the structural frame of wheelchair is ready to be installed with electrical component with 12 volt and 5 volt DC battery and button control configuration. They were plugged in into breadboard, and finally, a complete installation of the hardware and electrical component are the final assembly product.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohammed Ijmal Kamil bin Patriot. Today in my part, I will present on simulation that we did in our project as well as estimation of the cost. Since we are currently facing with COVID-19 pandemic, we had to choose either to do the prototyping in simulation prototyping or physical prototyping. Finally, we have been decided to go with simulation prototyping. Let's take a look at our simulation. In simulation prototyping, we use dynamic simulation to simulate the structural analysis. It consists of total deformation, von Mises stress or equivalent stress, and total strain. The second simulation we do is kinematic simulation. Kinematic simulation, we use linear actuator and we simulate how it react and how it applicate in real life for our 3D design. The third one is electronic component simulation, where we use the control driver module and we simulate in Proteus software to simulate the functionality of our 3D design. Before we look to the dynamic simulation, let's take a look at the mechanical properties for the material stainless steel 304. Stainless steel 304 used as an input material in the ANSYS before we do the simulation. The density of stainless steel 304 is 7.86 mg per meter cube. Modulus of elasticity is 193 gigapascal. Modulus of rigidity is 75 gigapascal. Yield strength is 207 megapascal and the Poisson ratio is 0.27. When we do the dynamic simulation, we approximate the human load at the surface of the backrest and seat. For the backrest, we do the 20 kg or 190 Newton. For the seat surface, 100 kg or 981 Newton. The first picture you can see here is the total deformation result from ANSYS simulation based on structural analysis, input material and input load. You can see here the reference is dark blue as a minimum and the red color as a maximum total deformation. The result from the rigid body of the wheelchair we can get is 0.016288 meter. In millimeter, it is 16.288 millimeter. Now, the second picture is the equivalent stress. We can see here the maximum stress that wheelchair can withstand is 1.3499 gigapascal. Last but not least is equivalent elastic strain. As you can see in the picture, the light blue shaded region shows the area which is the most strain occur. The result from the analysis is the maximum is 0.006824. This is the video of total deformation resulting from equivalent stress and strain. Let's take a look at how deformation occur. From the video, we can see the dark blue region shows the zero or minimum load applied until the red region as the maximum deformation occur. That is the region where 980 newtons is occur. Now, this is the kinematic simulation for the wheelchair to elevate using the linear actuator mechanism. Let's take a look on how it works. The video shows how the linear actuator mechanism works. It's elevated by rotating the linear motor inside and push the rod and frame together with the same RPM to move upwards and elevate at a certain height. As you can see here, we start at 0 as a minimum height to the 100 mm or 0.1 meter as the maximum height of elevation. Last simulation that we do in our project is electronic component simulation. This is the schematic diagram for the driver control module. It shows the interface between the user button configuration and the driver to move forward, backward, turning right, turning left, elevates upward as well as downwards. In this simulation, we are trying to imitate those motion by creating the direction of motor in turning clockwise and anti-clockwise. The flow to run the simulation is first we construct components in schematic capture in the Proteus. Then we create Arduino code programming in the Arduino IDE software. We run it and we implement in the Arduino Uno board in the Proteus. And we run the simulation as the component react as a function in real-life application. Let's take a look at the video. First, we turn on the button. So this is the button configuration for the user interface with the driver motor. Forward button push, create a motion forward by rotating the motor, right motor clockwise, left motor counterclockwise. Same with the reverse, but the direction is different. The right motor will reverse in counterclockwise, left motor will in the clockwise motion. Now in turning right and left. Turning right. With turning right, one motor is stopped at the right motor and the left motor will rotate counterclockwise. For the left or turning left button, the right motor will turn in clockwise direction and the left motor will stop. So for the linear actuator, elevation motion, up button, the linear motor will rotate at the same RPM in clockwise direction. For down button, it's declining and rotates at the same RPM in counterclockwise. So let's say the motor is functioning and we are having emergency button. Push the emergency button and then everything will stop automatically. This is a safety precaution built inside the system. Now we have done with the simulation, let's move on to our economical cost. First thing first is bill of material, or we call it as BOM. The BOM is the summary list for the material and component to build one product. In our project, to build one product, it costs us 1,626 ringgit and 89 cents for one smart transfer wheelchair. Here is the cost and profit calculation. Based on the product of smart transfer wheelchair, we can get the cost of goods from the BOM is 1,626 ringgit and 90 cents. We rounded off. The net sales we approximate to be 2,059 ringgit. The gross profit is 2,059 ringgit minus with the cost of goods. We get 432 ringgit and 10 cents. For the gross profit margin, we divide the gross profit with the net sales and times with 100%. We get 20.99% in gross profit margin. This shows it is a healthy profit accountability. Income statement per 150 products. This table shows the economic analysis, income, and expenses per 150 products. Let's take a look one by one. Table 1 shows the economic analysis. The calculation as shown for 150 products. The price for net sales is 308,850 ringgit. Cost of goods is 244,035 ringgit. The gross profit as shown, net sales minus cost of goods, 64,850 ringgit. Table 2, income and expenses per 150 products. Operating expenses is the selling expenses, general expenses, and administrative expenses. And the total operating expenses is selling plus general plus admin expenses. So the total for this cost is 2,070 ringgit. For income, we have operating income, other income, interest income. So the total is operating plus other income plus interest income. The total is 2,040 ringgit. Income before taxes will be 900 ringgit and income taxes is 270 ringgit. This is the estimation value only. The real life is maybe vary due to the real situation. So the net profit is gross profit plus total income minus total operating expenses minus income before and after taxes. So we conclude that the total is 63,615 ringgit. The gross profit margin is equal to gross profit divided by sales times 100%. The result is 20.99%, still same as the profit margin for one product. So this is shown as a healthy accountability for the profit. Profit margin ratio, net profit over sales amount times 100%. We can conclude that it is a 20.6%. Based on profit margin of 20.6%, it indicates that the proportion of sales revenue turned into net profit. For this case, the net profit margin of 20.6% means that for every RM 2,050 ringgit, 59 ringgit sales contributes toward the net profits of the business. Net profit margin ratio is one of the two elements that determine the return on assets, the other element being the sales turnover ratio. Measuring the trend of profit margin over the several periods in the comparison to industry benchmarks is crucial for identifying gaps that could be overcome to improve the profitability of business in the future. That's all for me. Thank you, and I will pass to my friend Hasan.
Assalamu alaikum warahmatullahi wabarakatuh. My name is Hasan Abulghaith Meenah. Today I'm going to explain our last chapter in our IDP project, which is discussion and conclusion. First of all, concept prototyping. Through the market survey done by questionnaire delivered to the local generally the concept of this product pattern to transfer the user into or out of it. The design consists of 4 wheels and 2 linear actuators. The wheels are to ease the user to move around, to transfer the user into out of it. Linear actuator is implemented to increase and reduce the height of seat, while the C-shaped seat, which is designed to carry the user from bed to the wheelchair. The design also consists a lock to avoid the separation of the seat and controller to the direction of wheelchair. This product is rechargeable and can be used for a long time duration. Next, which is the discussion and solution justification. It consists of 2 main parts, which is material component and manufacturing. The material component, material chosen is a virtual stage in order to make this product long-lasting and can be reused and recycled. Materials need to carefully selected in order to suit the design in order to optimize the performance. One of material consideration is done on the frame of the wheelchair. Stainless steel is chosen as a material in marketing this product. The manufacturing. In order to manufacture the wheelchair, 1 battery is used as a direct current DC supply. 1 battery with 12 volt for lifting mechanism, which means the linear actuator, and wheel motor. This is because the voltage can be supplied to the motor with linear actuator and wheel motor. Battery is suitable for lifting and movement of tires, as it has a high starting torque. Next, which is the sustainability. Sustainability refers to the characteristic of national fiscal policy, personal budgetary policy, and environmental policy. It's a more technical performance characteristic than durability and is measured by the probability that a product will neither malfunction nor fail within a specific time period. Design for sustainability is a systematic, streamlined, concurrent engineering program in which the sustainability engineer is weaved into the total development cycle. Next, which is the impact to environment and society. The impact. The Code of Ethics requires an engineer to prioritize the safety, health, and welfare of public, and consider the environmental impact and sustainable development of their duties. Future engineers must practice the code of conduct in order to complete this project by taking in account the impact that this product causes to the society and community. For the concept of this product is based on the foundation of automatic system that eases the accessibility of the user. For the next one, which is the conclusion of our IDP project. To conclude this project for really, the virtual prototype that had been developed is able to achieve the objective set in the beginning of this project. The virtual prototype is able to transfer the wheelchair user between the wheelchair and bed without assistance from others. This is achieved by the C-shaped seat and linear actuator. Furthermore, it equipped the wheel of braking system, which is to hold wheelchair stationary and keep the user safe while transferring to other equipment. The development of wheelie brings convenience for both the wheelchair user and the caregiver, as it helps the wheelchair user to become more independent and reduce the caregiver's burden on helping user to move between the bed and the wheelchair. Next, recommendation. To improve functionality of wheelie, the ASIF recommendation can be made. First, an electrical wheelchair should be powered by a cell gel and lead acid batteries instead of lithium polymer. Besides that, the design of the wheelchair recommended is to be foldable and lightweight, so the user is able to keep the wheelchair by his own. In future, wheelies should be designed in foldable, portable, and lightweight approach. That's it for our last chapter. Thank you.